And we are back, folks. Sorry about the delay there. Had some technical difficulties. My Surface decided to update. So it's been happening more and more frequently when I head into the office here. So we were on the composition of functions, so f composed with g of x. So let's do that. We have f of g of x. So the other way we write that, when you see that open circle, it's not multiplication, it's this. You're basically going to plug in g of x everywhere you see an x. So it goes something like that. You see that x right there. So we're going to plug this in. This goes 5 times, and I'll just write g of x for now. We'll deal with that in a second. Minus 1. Okay? And what does this become? Well, this is 5 times, what's g of x? Well, g of x is this x squared minus 2x plus 10 all over 4 minus x. And then we have minus 1. Okay? So our final answer, if we want to write it, we can write it as 5x squared. You got to multiply 5 times everything. 5x squared minus 10x plus 50 all over 4 minus x, and then minus 1 would do the trick. Okay. Hopefully that makes sense on that one. If not, just let me know. There's a question box there, so please keep me informed. So in the next one, we're going to do something similar. I'm going to draw this just to make some room as g of f of x. So this is going to be a little bit trickier. This is going to put all the f of x's in for the x's in g. So we got an x there, we got an x there, and we got an x right there. So this becomes f of x, the quantity squared, right, minus 2 times f of x plus 10 all over 4 minus, and then it goes f of x. So remember, f of x is 5x minus 1, so we're going to just plug that in right here. Just get 5x minus 1, the quantity squared, minus 2 times 5x minus 1 plus 10 all over 4 minus, we have 5x minus 1. Okay, so taking a look at that, what does this become? Well, 5x minus 1, the quantity squared, that's going to be 25x squared. Then you multiply 2 times the product of those two, so it'll be minus 10x. Then plus 1. Multiply 2 times all those, so minus 10x. Plus 2. Then plus 10. Okay, and then all that's divided by our 4 minus 5x, and then we got to add 1 there. So what does all this equal at the end of the day? Well, we have 25x squared. There's no other x squareds there, so we'll just put that down, 25x squared. Minus 10x and another minus 10x makes minus 20x. And then we have plus 1 plus 2, which is plus 3, and plus another 10 is plus 13. And then all over 4 plus 1 makes 5 minus 5x. And notice 1 will be a solution to that. You can plug in 1 and see right away it's not going to be a solution, so this would be a simplified format. One of a few versions of it too. So hopefully if you have any questions, once again, please ask right away. I'm happy to answer them, but I don't see any, so you see how this has been multiplied out and all that song and dance. So let's take a look at our next problem. Find the inverse of x, where f of x equals 7 times the quantity x minus 4 cubed minus 8. So with these, there's a series of 3 steps that I like to do, and so we have a step 1. So our step 1, what is it? Replace f of x with y. Simple as that. So we go y equals 7 times the quantity x minus 4 cubed minus 8. Now I should mention as well, this is a one-to-one function. So in order for an inverse to exist, we need our function to be 1 to 1. So that's something we're always going to have going on there. So now step 2, this person has a little bit different size foot there. What we're going to do with all these inverses is the same process over and over again. We're going to just solve for x. So now, how do we solve for x? Well, you try and isolate whatever's going on with the x business into one grouping here. So we'll move the 8 on over, so we get y plus 8 equals 7 times the quantity x minus 4 cubed. And this is usually the hardest step, I'll be honest with you. This takes the most time. And so our next step there would be to divide both sides by 7. And now we have a cube over on that right hand side. How do we get rid of the cube now that that x minus 4 is grouped inside of there? So the way to get rid of the cube is to take the cube root. So we take a cube root of both sides. We get y plus 8 over 7 equals x minus 4. And then we will solve for x here just by adding 4 over to the other side. Cube root of y plus 8 over 7 plus 4. Okay, so now for our last step, this is the easy one, but most people forget it. You replace x with f inverse of x, or g inverse of x if you're dealing with g of x or whatever the case may be, and then replace y with x. Now I'm just going to write them on different sides, so I'm going to bring the x on over. So we get f inverse of x equals the cube root of, now y is replaced with x, so that's x plus 8 over 7, and then plus 4, and you're done. And you could do these all day long. It's the same process over and over again. Just remember the 3 steps right over on this left hand side. As long as you do that, same song and dance, you can do it over and over again. Okay. So now for the vertex of a quadratic function, there's a couple ways to do this. We can do the completing the square process, which you may or may not remember. So completing the square process is we're going to have to rewrite this. So first off, you get 5. You can factor that out of the first 2 terms, so you get x squared minus 4x. Then we have that plus 3. And then we have, you want to complete that square, so notice you take half of the middle term, which is 2, and you're going to square that on the inside. So notice we'll go 5, and then we'll write x squared minus 4x plus 4 would be a perfect square. But I just added 4, so I have to subtract that 5 times 4 as well, right? Because we have 5 times this 4 here. But that'll be a perfect square on the inside. That's the whole purpose of completing the square. You want to get a perfect square. The perfect square that we're looking at there is x, oops, not plus 2, minus 2 is what we have. X minus 2, the quantity squared. Okay, so we have f of x equals 5, and then it goes x minus 2, the quantity squared, and then notice this is minus 20 plus 3, so that's minus 17, and that's our final answer for completing the square, right? Or I shouldn't say final answer. So what does this mean as a vertex? Well, the vertex, what we have to do then is try and figure out, okay, where's this max and min thing sort of occur? So in this case, we have a vertex at this value right here tells you how the things have shifted. So what we've done is we've shifted to the right 2 units, and we've shifted down 17, so negative 17. And it's not going to be perfect because we're going to have a vertical stretch as well, but you get a graph like that. So notice this vertex is at 2, negative 17. Just from the shifts, you can see that. Okay, that's where it ties into the transformations of functions. That's one way of doing it. It's not the only way, though. So another method that's pretty useful. If you have ax squared plus bx plus c, let's say this is a function g of x, then what we have is the vertex occurs at negative b over 2a, and then it goes c minus b squared over 4a. So and remember, x and y values is what we're getting at. So x values, we can find that first. So we get the negative b over 2a. So this is a, b equals negative 20, by the way, and c equals 3. So a equals 5, I'll write down 2. Negative b over 2a. So we get negative, and then b is negative 20 over 2a, so that's 2 times 5. Okay. C minus b squared over 4a, right? So you get 3 minus b squared is negative 20 squared all over 4a, so that's 4 times 5, right? Okay, so if you simplify this, you can cross off some things real quick, but notice you reduce this down. This is 2, and then you can cancel off. This is 20. It'll cancel off a part of that 20. And so you get negative 17. And so you get the same values. It's just a lot quicker. That's the whole idea. So you can use either method. I don't care which one you use, but I want you to be aware of both. So that's how you can find a vertex. And as we saw, though, the more useful information is actually completing the square. We know that not only do we have a vertex there, we know it's a minimum. Okay. All right. So now moving on to roots of polynomials. Descartes' rule of signs here. How does this work? Well, what Descartes found is that, hey, if we list this thing in a decreasing order, so let's actually do that. And when I say decreasing order, talking about the degrees of the polynomials or the actual values. So notice we start with that negative 7x to the 7th. Okay, then so we have plus x to the 6th, plus 2x to the 5th, plus 3x to the 4th. And notice how we're just going and counting down. And then now we have minus 4x cubed minus x squared. Notice there is no x, and then we finish with a plus 9. Okay, so you can figure out the number of positive and negative 0 possibilities, I should say. So we'll do positive 0 possibilities. Okay, all you need to do is look at the number of change of signs. So let's kind of comment on that. So notice we switch once from there to there. We switch a second time from there to there. And then we switch a third time from here to here, right? Does that make sense? Okay, so hopefully it does. So notice this is 3 possibilities. But now Descartes' rule of signs says 3 isn't the only possibility. We could also have 2 less than that. So it's always an even number less than whatever the maximum is. So 3 or 1 possible zeros. And the reason is you kind of have a balancing out effect when you plug in the positive numbers. So that's where that idea comes from. Now for the negative 0 possibilities, it gets a little bit trickier. So for negative 0 possibilities, we're going to need to look at f of negative x. And so notice first off that makes 3. We have negative x. Oh, sorry, I started with the top equation. We already have f of x written in the other form. So negative 7, and we'll go negative x to the 7th plus negative x raised to the 6th plus 2 times negative x to the 5th. Plus 3 times negative x to the 4th minus 4 times negative x the quantity cubed minus negative x the quantity squared, and then plus 9. Alright, so what does this make? Well, at the end of the day, we have a negative raised to the 7th power. That's going to make it all negative, so negative times negative makes it positive. You get 7x to the 7th. Okay, our next one, so that is plus x to the 6th. Our next one, we have, oops, I should have put the 5 outside. Sorry about that. So we have this x, and then the fifth, this should be out there. But either way, you're going to get negative 2x to the fifth. The 3 will turn positive because when you raise negative x to the fourth power, that just becomes positive x to the fourth, so that's 3x to the fourth. The cube, you go minus and a minus makes a positive, so that's positive 4x cubed. Negative x to the quantity squared. Notice it's going to be positive x squared, so that's going to be our, we have negative out in front of that, so it's negative x squared overall, and then plus 9. So now, going to our solution, how many times do we switch signs? So you have once, you have twice, you have 3 times, and you have 4 times. Okay, so our number of negative 0 possibilities. A little bit more interesting in this case. What do we have? Well, we have 1, 2, 3, 4, but remember we reduce 4 or 2, or reduce them by even numbers each time, or 0. Possible negative zeros. Okay, so when you plug in negative numbers, there's more possibilities. A higher number of possibilities, but it doesn't mean that's going to be the case. It just means that those are the possibilities. So you could not have 1 negative 0. That's what it's saying. Okay. Descartes' rule of signs, kind of a cool rule where all you have to do is just check plus and minus signs. It's really nice and easy. So last but not least, we're going to finish with asymptotes. Okay, when looking at this function here, we have a fraction, so we're going to have asymptotes. Now there's 2 varieties. There's the horizontal asymptotes and there's the vertical asymptotes. So the horizontal is really easy. You check the degrees. Okay, so we check the degrees. Degrees are the same, so that means you just look at the leading coefficients out in front. So the horizontal asymptotes occur at y equals, so we take the leading coefficient, which is 3, and the leading coefficient down below, which is 1, when the degrees are the same. Now the other cases, if the degree of the numerator is greater than the degree of the denominator, you have no horizontal asymptote. And if the degree of the denominator is greater than the degree of the numerator, then you have a horizontal asymptote at y equals 0. But since these match, you have a horizontal asymptote at y equals 3. Okay? And now for the vertical asymptotes, we need to do some work. So we got to factor this crazy thing. So we have a difference of squares in the denominator, so that's x plus 5, x minus 5. And so, and then in the numerator, let's see here. I think we can factor that. So notice we'll need a 3x and an x. And we need to multiply to negative 10 and then have this 3 times one of those values plus the other value end up giving us negative 13. Let's see. If we go negative 5 on this side, notice that makes negative 15x, and then we go plus 2 on this side, that makes plus 2x. Negative 15x plus 2x makes minus 13x, and then that also gives us negative 10. And so that would do it. Now, what this says, though, this actually gives us some useful information. This piece right here, usually we just look at the denominator, but it isn't that simple all the time. We have a common factor in both the numerator and denominator. And this is tells us, since you have x minus 5, and by the way, x minus 5 equal to 0 means x equals 5. Since it's in both the numerator and denominator, it's a whole at x equals 5. Okay, so that means the only vertical, so this factor here corresponds to the vertical asymptote should occur at x plus 5 equals 0. So notice you just solve by subtracting 5 from both sides. You get x equals negative 5. And so our solution, we only have one vertical asymptote. It's x equals -5. And that's our solution. Okay, so that's all there is to it in terms of horizontal, vertical asymptotes and that whole song and dance. And you can, as I said, just watch out for where we have some canceling going on in the numerator and denominator. That's the only one where you get a hole. I wanted you to see that case of what happens there. But so I don't see any questions popping up. Sorry for the technical difficulties along the way, but hopefully this helps with your review. And best of luck on that upcoming exam, folks.